If you've been watching my videos, you know I'm trying to repair an HP9830A desktop calculator, and I've got as far as identifying what I believe is a problem with the ROM card. And what I've been doing is hooking the ROM card intact to a ROM reader and trying to extract the data. And I had some issues with the data that I was seeing not being the same as what I was getting when the card was in the machine. So I've been playing with the timing from the programmer, and what I now get is pretty much identical to what I'm seeing in the machine. But of course, when I read it in the EEPROM reader, then what I get is a binary file like this. And of course, it's not particularly useful in this format. So what I've done is written a small software utility that takes this file and it converts it into a human readable form in a similar format to the code that's shown in the HP patent. So I'll just give a quick demonstration. All I need to do is select a source file, and this is the binary output file from the EEPROM reader, give it a name, and then I can decide whether I want the data inverting or not. If you've been watching the videos, then you'll know that the ROM card in the HP feeds its output data into the T register, and the T register has inverters on its input. So what the machine actually sees is the inverted version of what's in the ROMs. So what I want to be able to do is look at the corrected value, if you like, without having to do the kind of mental conversion as I scan through it and test it against the values in the patent. So that's what this checkbox does. It allows me to invert it or just pass it straight through as straight octal conversions. And then I just click on Process File, and what I end up with is a file like this. And if you've seen the patent, you'll recognize this as being very similar. We have the line number on the left in octal and the value for the instruction on the right in octal as well. And so this is now very easy to compare against the values in the patent, which is what I've been doing. And for the most part it is the same, but there are some errors in this, so it does look like the ROM card is at fault. But this is possibly close enough where I can make manual corrections in here, and then what I'll do is create another utility that does the reverse. It will take the octal values, turn them back into hex, so that I can import them into my EEPROM writer, write an EEPROM, and then attach that to the HP and see if it works. Of course, it's not as quite straightforward as that, because the HP has some odd decoding, because the ROMs it uses are only 512 bytes. So I will have to unencode that and turn it back into straight address bytes so that the ROM will work properly. But the first step is to get this code converted and corrected, and then hopefully I can get it programmed into a ROM and see if that is going to get the HP running. As ever, any comments, advice, help would be appreciated.